All right, guys. Time to take a look at our homework problems for lesson 66. So you can go ahead and set up your paper. All right, lesson 66 right here, and it looks like we've got 17 problems to tackle. 1 through 6, 8, 10, 12, 14, 17, and 20 to 25. All right, cool. Let's get started. The first problem we have, I'm going to move my book. Sorry, I should have put it over here just to make it a little easier for myself. Okay, number 1, simplify the rational expression if possible. And it looks like we've got 3 of these to do. So we're going to start with number 1, 11p over 6s to the 4th plus p over 6s to the 4th. Okay. When I simplify this, because my denominators are the same, I can add straight across the numerators, and I end up with 12p, because I had 11 here and 1 here, and my denominator remains 6s to the 4th. Now I'm not quite done, because I have 12 over 6. 12 over 6 is going to reduce down to 2, simply 2, right? 2 over 1. So now I have 2p over just s to the 4th. So that is the answer for number 1. 2p over s to the 4th. Number 2, similar. 4x over 5w to the 4th minus 5x over 5w to the 4th. Don't you love it when the denominators are common like that? That means we can just add or subtract straight across the numerators and leave the denominator unchanged. So my 5w to the 4th comes straight over, and I've got 4x minus 5x, which is just negative x, right? And there's nothing more I can simplify, so that is my answer. Negative x over 5w to the 4th. Okay. Number 3, 7y over 3x to the 4th plus 1 plus 5y over 3x to the 4th plus 1. Great. Because these, now the denominators are the same, right? So my denominator just comes over unchanged. And because these are like terms, right? They're both a y with a coefficient, I can just add them together. So 7y plus 5 more y's is going to be 12y. Now, can I simplify this any further? No, because there's nothing that I can factor out of 3x to the 4th and 1 to make it any simpler, which means this is my answer. 12y over 3x to the 4th plus 1. Great. Okay, number 4, we're going to solve this inequality. So I've got 7 plus 10 is greater than or equal to 3. Right? Right. Okay, I'm going to go ahead and subtract 10 from this side to move it from this side over here to this side. So I've got z is greater than or equal to negative 7. It doesn't say that I need to graph it, so I'm not going to. And I didn't need to flip this sign because I didn't multiply or divide, right, by a negative number. I just subtracted. So that inequality sign stays the same direction, and my answer is simply z is greater than or equal to negative 7. Number 5, x minus 4 is less than or equal to 9. All right. The inverse operation for subtraction is addition. So I'll add 4 here to move it from this side of the inequality to, oops, that's a 4, to this side, and I'll end up with x is less than or equal to 13. Again, I don't need to graph, and I didn't need to flip that inequality sign because I wasn't multiplying or dividing by a negative number. It looks like for number 6, I am going to need to graph the inequality. So that means, since it's an inequality, when it says graph, it doesn't mean on a coordinate plane, it means on a number line. And here's my inequality. Z is less than or equal to 1 2/3. All right, so I'm going to go ahead and draw a number line here. I think I'll put, now because I'm dealing with thirds, right, I want to make my tick marks on my number line equal to thirds, so I think I'll start with 0 right here, and this will be 1/3, 2/3, 1, 1/3, 2/3, 2, 1/3, 2/3, 3, and we'll just end at 3 2/3 there. I'm going to grab a colored pencil because I happen to have one right here next to me. And because there's an equal than, this is less than or equal to, it's going to be a solid dot. I'm going to plot my point at 1 2/3. Here's 1 1 2/3. It's going to be a solid dot because of that equal to sign. So it includes this in the solution set as well as all of the values less than 1 2/3. Okay, looks like that. And I'll just write C number line, my answer column. If you're not using an answer column, this is sufficient. Okay, just make sure your work is neat enough for me to tell clearly where your answers are. And we're moving on now to number 8. All right, let's see. Define a linear function that has shifted upward 3 units. All right. It doesn't say explicitly here, but what they're asking us to do is to write an equation. So I already know that the definition, right, or the parent equation of a line is f of x equals x, right? Y equals x, or f of x equals x. Because it said linear function, I'm going to write it as f of x equals x, but it's shifted upward. So that means that my y-intercept is going to be +3. Right? Because it's shifted upward on my coordinate plane, it'll intersect at +3. So here it is. There's my definition. And I'll just rewrite it over here. F of x equals x plus 3. Okay. Number 10. In 2 similar triangles, the lengths of the sides of the larger triangle are directly proportional to the lengths of the corresponding sides of the smaller triangle. Find the length of x. All right, so for number 10, we've got 2 triangles, right, guys? We've got a big one, and then we've got a small one. It's quite small compared to the other, but they are similar. So that means that their side lengths are proportional. Their angles would be equal, and their side lengths are proportional. So this is 14 millimeters, 10.5 millimeters. I guess I should have drawn this bigger. Oh well. This one's 4 and this one's x. All right, so I'm going to set my proportion up, and as long as I keep my proportion consistent, this should be fairly straightforward. Okay, all right, so this side length, 14, is proportional to this side length, 4. And I can set that equal to 10.5 over x. Now, when I do my cross multiplication, I should find, right? So I'm going to cross multiply these terms, and then I'm going to multiply these terms. I'll set them equal to each other. So I will have here 14x equals 10.5 times 4, which ends up being 42. And in order now to solve for x, because 14 times x, right, this is a multiplication, so I'm going to do the inverse operation and just division. Divide out that 14, and I get x equals 3. My units are millimeters. So the answer to number 10 is 3 millimeters. Great. Okay. Number 12. Page. What is the solution to 3z plus 2 is less than or equal to z minus 4 plus 2 plus z? Oh my goodness. All right, so for this one, I need to solve, or simplify anyway, because that's what they're asking me, right? What is the simplification of this whole mess? Which means I need to combine like terms first on this side, and then I can start moving terms around. So I'm just going to rewrite these as they are because there's nothing for me to combine on this side. However, on this side, I can see I've got a z and a positive z, so that gives me 2 z's, and I've got a negative 4 plus 2, which is minus 2. Okay, now let's go ahead and move the 2z. I'm not going to divide it, I'm going to subtract it because I need to move the entire thing. Okay, subtract my 2z right there on this side, which 3z minus 2z is simply z. I'm going to move the 2 over here from this side, subtract it over here, and move it to the other side, which is going to give me is less than or equal to negative 4. Okay, and I see that that is letter A, so my answer for number 12 is A. Because that is the inequality that matches my solution. All right, let's see. I'm going to keep going here. Getting close to being done. Move my paper down. And it looks like we are on number 14. Multi-step. In a student poll about yearbook covers, every 12th student likes blue, every 16th student likes red, and every 28th student likes white. How many students are polled before one student likes red, white, and blue? So if you guys remember, this is where we are going to do our prime factorization, right? So we've got these three numbers, every 12th student, every 16th student, and every 28th student. And we're going to find the least common multiple by completing the prime factorization for each one of these. Here, let's just do it together, all right? So let's say 3 and 4 and then 2 and 2, all right? So here's my prime factorization for 12. For 16, I'm going to have 4 and 4 and then 2 and 2 and 2 and 2. And for 28, let's go 7 and 4 and 2 and 2. Now, when I find the least common multiple here, let's see, the factor that has 2 represented most is the 16, and I've got 4 2's, right? So that's the most number of 2's that I need, so I've got my 2's taken care of. I've got 1 3, and that's the only time it shows up, and I've got 1 7, all right? So when I multiply all of those numbers together, let's just do that. I'm going to do it on my calculator. 2 times 3 times 7. I get 336 students. So that's the answer to letter A. That's for 14A. Okay, how many students are polled before one student likes red, white, and blue? The answer is 336 students, because that's the least common multiple of all of those factors. And now let's do the work for letter B. If 1,200 students are polled, how many like red, white, and blue? So if I've got 1,200 total students, and I know that every 336 like red, white, and blue, right? Then I should be able to take 1,200 and divide it by this number, my 336, which I just did on my calculator, and I got approximately 3.6. So because we can't have 0.6 of a student, my answer is just going to be 3 students. If 1,200 are polled, 3 of them will end up liking red, white, and blue. Alrighty, number 17. Which of the equations has the solution y equals 5? Okay, as I look at this, and I'm just looking at it right now, do I need to do every single one of these in order to answer this question? y equals, which one of these equations has the solution of y equals 5? Well, I guess we can just go ahead and start to solve here, and then we'll get our answer. So let's start with the equations that we have here in letter A. Yeah, let's do this guy. Okay, plus 5y equals 16, and 2x plus y equals -4. Now I want to solve for y, and I can see that if I multiply one of these equations by -1, that I can eliminate that 2x. See that, guys? Okay, so I think actually I'm going to, I'll go ahead and multiply, I guess, the bottom one by -1, and then I'll add them together and let's see what we get. Okay, so I'm going to leave this one unchanged, 2x plus 5y equals 16. Now I'm going to change all of the signs for this one so that I end up with a -2x minus y equals, in this case, it's a -1 times 4, a +4. Now I'm going to combine those, so I get 20 here. Those eliminated, which is what I wanted, and I get 4y equals 20. Awesome! Because when I divide this by 4 and this by 4, I will get y equals 5. And the question was, which equation has a solution of y equals 5? Dun dun dun! I found it on the first try. Sweet. It is letter A. Those are the two equations that I just worked with. And I just figured out that they have a solution of y equals 5. Great. Let's go on to number 20. 5 more problems. 2 students are using the product rule to find the missing value. Which student is correct? Explain the error. So we're working with this rule where x1, oh, I see. Well, goodness sake. There's the error right there. You see what student A did? Student A said x1, y2 equals x2, y1, but that's not the rule. The rule is what student B wrote. x1, y1 equals x2, y2, right? So student B is correct. Because student A did not write the rule correctly. So the error was in the very, very beginning. This is the product rule. So I don't even have to look at any of the rest of the calculations. I already know that it's student B that got the answer right, because student B is the one that wrote down the equation in the right order. All right, number 21. Write a direct variation equation relating x and y when x is 5 and y is 30. Okay, so we need to remember that our direct variation relationship between x and y is y equals kx. Remember that, guys? Okay, so I've been given this information that x equals 5 and y equals 30. My equation that I write should be in the form y equals, I need a number right here, and then x. So thankfully I got these two numbers so I can solve for k and then put it back into my equation. Okay, so y is 30 times, I don't know what k is, that's what I need to find out, and x is 5. So that means that if I divide this side by 5 and this side by 5, I will discover that k is equal to 6. I can now take this information and put it into my direct variation equation so that it ends up looking like this. Y equals 6x. That's what I'm looking for. Okay? That's the direct variation relationship between x and y. And we were able to solve for k. Good. It looks like problem number 22 is asking us to write an inverse variation relating x and y when x is 4 and y is 20. Okay, so I just need to remember here that my inverse equation showing the relationship between x and y is y equals, do you guys remember this? Okay, remember kind of how we found this? That y is going to equal k over x. This is the ultimate form of equation that I want to end up with, but I need a number for k. I need a value. So I'm going to go ahead and substitute in. They told me x equals 4, y equals 20. So I'm going to solve for k. Okay, so here's 20 equals k over 4. In order to get k by itself now, I'm going to multiply each side by 4. So I just get k, and I'm going to multiply this side by 4. And I find that the value of k is 80. I'm going to take this and stick it back into this equation now to show my inverse relationship, and I get y equals 80 over x. So that's the answer. Okay, we are almost done. Problem number 23, multiply. Here we go. I've got two binomials, 2x minus 3 and 2x minus 3. Okay, I don't know if you guys remember our special product rule for this or not, but let's just go ahead and do our kind of normal distribution, which is FOIL. You remember that, guys? And then we can talk about special product rules, but in any case, we're going to multiply the first terms first. So 2x times 2x is 4x squared. Now I'm going to multiply the outer terms, 2x times negative 3. So 2x times negative 3 is negative 6x, not 6x squared, because this is just a 3, right? So I only have one x here, so it's negative 6x. Now I've got my inner terms, negative 3 times 2x, which is another negative 6x. And then I multiply the last terms. Negative 3 times negative 3 is positive 9. I'm going to simplify. I've got minus 6x minus 6x. Be careful, okay? Those don't cancel each other out. They're both negative, which means I end up with 4x squared minus 12x, not 12x squared. These are both just x's, plus 9. All right. That's the answer to number 23. 4x squared minus 12x plus 9. 2 more problems to go. I need a new piece of paper. I'll bring that down here. And I'm on number 24. T minus 12 times t plus 12. You might remember that we have a special products rule for this, where we have a minus b times a plus b. The answer, if you remember, right, is going to be a squared minus b squared. We're not going to have a middle term, and that's because when we multiply the inner terms and the outer terms, they're going to cancel each other out. See that? I'm going to end up with a 12t in the middle and a negative 12t right next to it, and they'll cancel each other out. So instead of doing FOIL, I'm going to just follow my special product rule for this guy and end up with, so if it's a squared minus b squared, here's the a term, right, t and t, so my first multiplication becomes t squared, and then 12 times 12 is minus 144. That's the answer. So I told you guys, pretty soon you're going to be able to start doing these in your head, if you can retain the knowledge of those special product formulas especially. Okay, here we go with y cubed minus 4 times squared. Okay, y cubed minus 4 squared. So if I was going to write this out, it would come out to be, right, so I've got two binomials here, y cubed minus 4 times y cubed minus 4, because it's this whole term multiplied by itself. Okay, so for this guy, I've got, let's go ahead and use our FOIL. Okay, for this, multiply our first two terms together. And remember, when I multiply exponents, I add them. So y cubed times y cubed is y to the 6th, right? Since I'm multiplying these guys, then I add those exponents together. The outer terms, y cubed times negative 4 is negative 4y cubed. And the inner terms, negative 4 times y cubed is, again, negative 4y cubed. And then negative 4 times negative 4 is positive 16. Now I could have used this same rule here. The reason I didn't is because I was dealing with cubes and not squares. But if I take the the principle that I understood, right? And I apply it to this, it really works the same way, but this is a little safer for us right now. So make sure you recognize that we've got two like terms here. They do not cancel each other out because they're both negative. So I'm already starting with -4, and then I got to go down another 4. So I'm going to end up with y to the 6 minus 8y cubed plus 16. And that is my final answer. Put it over here, y6 minus 8y cubed plus 16. All right, gang, I think that is it for this lesson. So I'll be back again for our homework in lesson 67.